Hello. Today we are going to start a new topic which is probability distribution and random variable. Now, what is random variable? A random variable is a way of representing each outcome of a sample space or of an experiment. For example, if we perform an experiment in which we toss two coins simultaneously. So in the sample space of this experiment, the outcomes we get is either we get two heads, one head, one tail, or one tail, one head, or we can get two tails. Now this is the sample space, and at this point we'll define a random variable x such that number of tails is obtained. So what we have to do here, we have to count number of heads in each of these, we have to count number of tails in each of these outcomes. So in the first outcome where we have two heads, we have number of heads equal to 0. So in this case, the value of x will be 0. So this is our random variable for the first outcome. Now in the second outcome we have one tail, so value of x will be equals to 1. Similarly, in the third case we have one tail, so x will be equals to 1. And finally in this case we have two tails, so value of x will be 2. So this is a random variable for this experiment, and through this experiment we can say that a random variable is a real valued function. This x takes input from the sample space and its domain will be the sample space, and the output will be some numerical value. So the definition of random variable is a random variable is a real valued function whose domain is sample space of the random experiment. So in this case the sample space of random experiment was this, and this was a real valued function which is apparently a random variable. Now we will learn how to calculate probability of a random variable. So in previous example we tossed two coins simultaneously and we got this sample space, and then we defined a random variable x such that number of tails obtained. And in this case we obtained three values of x, which is x equal to 0, x equals to 1, and x equals to 2. Now if we have to calculate probabilities of x equal to 0 and x equals to 1 and x equals to 2, then how do we do that? So let's first find out probability of x equal to 0. So x equal to 0 means now how many number of tails in this sample space. So how many possible outcomes are there in this sample space which contains no tails? There's only one outcome, which is head. So probability of x equal to 0 will be 1/4, where 4 is the total number of possible outcomes in this sample space. Now the second case is x equals to 1. X equals to 1 means how many outcomes are there in sample space which contains only one tail. So there are two outcomes, head tail and tail head, which contains two tails. So probability of x equals to 1 will be 2/4, and similarly probability of x equals to 2 will be 1/4, and this is how you calculate probability of a random variable. In general case, let's say we have a random variable capital X and whose values are from x1, x2, xn up till xn. So each of these corresponding x has their corresponding probabilities. So say x1 has probability p1, x2 has probability p2, and finally this xn has corresponding probability pn. So sum of all these probabilities, which is probability of random variable, will be equals to 1. So this summation we can write this in sigma notation, where p of x is equals to sigma equals to 1 to n, pi equals to 1, and this I varies from 1 to n, that is I is a natural number. So sum of all the probabilities in a random variable will always be equals to 1. And if we look at the previous example, we have x equal to 0, x equals to 1, and x equals to 2. So sum of all these probabilities will be equals to 1, because if you add 1/4, 2/4, and 1/4, the result you will obtain is 1. There are two types of random variable. The first one is discrete random variable. In this case, the values of x are discrete. For example, in our previous case where we defined random variable x to be a number of tails obtained, so in that case we had three values of random variable, which were x equals to 0, x equals to 1, and x equals to 2. So this is called discrete random variable. Now the second random variable case is continuous random variable, and in this case the values of x are not discrete. That is, for example, if we define a random variable x such that a car travels with initial speed at constant acceleration. So in this case x will be u plus at, where u is initial speed, a is x constant acceleration, and t is time. So with respect to time, this value will keep on changing, and hence the values of x will also keep on changing. So in this case, the value of x will not be discrete, rather it will be a continuous value. So we can say that x will belongs to R in this case. So these are the case of random variables: discrete random variable and continuous random variable. Now let's study distribution of random variable. Suppose we have a random variable x whose values are x1, x2, x3 and so on till xn, and its corresponding probabilities are p1, p2, p3 and so on till pn. Then the terms p of x equals to x1, p of x equals to x2 and so on till p of x equals to xn are called probability distribution of random variable x. Now there's another term which is cumulative probability distribution. So what is this? This means that if you want to find out probability of say p of x equal to x3, then you have to add all the previous values along with p of x equals to x3. So this is denoted by f of xi, where xi is the ith value of random variable x, and this is equals to p of x less than equals to xi. And from this, if you want to find out f of x1, then it can be calculated as f of x1 equals to p of x1, which will be equals to p1, but f of x2 will be equals to p of x1 plus p of x2, that will be equals to p1 plus p2. So current probability plus sum of all the previous probabilities. And similarly, you can find the p of f of xn, and that will be equals to p1 plus p2 plus c3 and so on till pn. And we can write it in sigma notation, that is sigma equals to 1 to n, p of x equals to xi, and this is always will be equals to 1. So these are the cases of distribution of random variable.